Hi class, this is part 2 of section 4.3, quadratic functions and their properties. Okay, so in this video we'll talk about functions that are in standard form, so ax squared plus bx plus c. We will still want to find the vertex, so the easiest way to find the vertex is to let x equal negative b over 2a. This will give you the x coordinate of the vertex. So then you just plug this number back into the function to get the y coordinate of the vertex. The parabola opens up if a is positive, and it opens down if a is negative. If it opens up, then there's a minimum value, and if it opens down, there is a maximum value. Okay, so in this example, we just have a bunch of questions to answer about one function. Okay, so f of x is x squared plus 4x. I'm going to start by finding the x-intercepts because I can see that this function is going to factor nicely. So to find an x-intercept, we let y equal 0. So I'll have 0 is equal to x squared minus 4x. Factor out the x. So we get x is equal to 0 and x is equal to 4. So our x-intercepts are the origin, 0, 0, and then oh, sorry about that. This should be a plus 4 right here, because in my function I had a plus, so let me switch those. Okay, so the x-intercepts are 0, 0, and negative 4, 0. Okay, so sorry about that. I rewrote it incorrectly, so it should have been x squared plus 4x, factor out the x, and then solve them both. Okay, so the second ordered pair is negative 4, 0. Okay, and then our y-intercept is also at the origin. Okay, so 0, 0. And negative 4, 0. All right. For the vertex, there's two different ways we can get the vertex. So first of all, the vertex must be halfway in between our two x-intercepts. So the vertex must be when x is equal to negative 2. We could also use the fact that x is negative b over 2a. So this would be negative 4 over 2 times 1. So we get negative 2. We want the y-coordinate of the vertex as well. So plug in a negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8, so we're really subtracting 8. So we come up with negative 4. So the vertex is negative 2, negative 4. Okay, and then we can sketch it from here. The axis of symmetry is the vertical line that goes through the vertex. So it is the line x is equal to negative 2. Okay, good. Our function opens up, and so that means it is concave up. Okay, graph the function. We did that, domain and range. So the domain is going to be all real numbers. The range we will get by looking at the graph. So we see that negative 4 is the smallest y value that we have, and then we go up from there. So the range is negative 4 to infinity. Okay. Part 5, determine where the function is increasing and where it is decreasing. Okay, so remember, these are always intervals of x. So our function, as we read it from left to right, our function starts out decreasing. Okay, so it's decreasing on the interval negative infinity to negative 2. And then it's increasing after that, so 2 to infinity. Negative 2. It's increasing negative 2 to infinity. Okay, so again, these are intervals of the x-axis. So if I'm here on the left side of the x-axis, coming up to negative 2, my function is decreasing. Once I get beyond negative 2, then my function switches to increasing. Okay, and then finally, determine where the function is greater than 0 and where it is less than 0. Okay, so these are the y values, right? F of x is the same thing as y. So looking on the graph, where is it greater than 0, meaning where is it above the x-axis? Okay, so the y values are positive in these two sections that I have colored in blue on our graph. So f of x is greater than 0. if I'm in the interval negative infinity to negative 4, union 0 to infinity. And then f of x is less than 0 if we're in between our two x-intercepts. So that would be from negative 4 to 0. Okay, and we're doing a few of these. So these last two are the hardest. Part 5, intervals of increasing and decreasing, that we have done before, but part 6 is a bit new. Okay, so we're looking at the graph and then we're stating on what interval of the x-axis, right? So here, these are all intervals of x, negative infinity, negative 4, 0 to infinity, negative 4 to 0. Okay, so our answer is intervals of the x-axis, but we're looking at the graph to see where the y values are positive or negative. Okay, same directions for part B. Okay, f of x is x squared minus 2x minus 8. This function is factorable, so I'm going to start by finding the x-intercepts. So I will let y equal 0. So we're looking for two numbers that multiply to be negative 8 and add to be negative 2. So negative 4 and 2, which means x is equal to 4 or x is equal to negative 2. So our x-intercepts are 4, 0 and negative 2, 0. The y-intercept, plug in a 0 for x, and we'll come up with negative 8. Okay, so 4, 0, negative 2, 0. That tells us that the vertex must be when x is equal to negative 1, because it must be halfway in between our two x-intercepts. Double check it, negative b over 2a. So the opposite of negative 2 is 2, divided by 2 times 1, which is 2. Oh, sorry, I said negative 1, I meant positive 1. And so we do get x is equal to 1. All right, we'll plug that back into our function. So f of 1 is 1 minus 2 minus 8. So we're at negative 9. So 1, negative 9 is our vertex. 0, negative 8 was our x-intercept. So based on symmetry, 2, negative 8 must also be a function on the graph. Okay, and then we can sketch it. Okay, so again, my vertex is 1, negative 9. If I go 1 unit to the left, I'm at negative 8. So if I go 1 unit to the right, I must also be at negative 8. That's how I knew this point 2, negative 8 was another point on the graph. Okay, domain of the function is all real numbers. The range, so the lowest value we have is negative 9. So the range is negative 9 to infinity. Determine where the function is increasing and where it's decreasing. Okay, so again, reading from left to right, our function is first decreasing. So it's decreasing on the interval negative infinity to 1, and then it's increasing after that, so it's increasing 1 to infinity. Determine where the function is greater than 0 and where it is less than 0. Okay, greater than 0, if it's here to the left of that first x-intercept, or if it's to the right of my second intercept. Okay, so if I am at any x value that's here on the left side of my x-axis, so anything that's less than negative 2, if I take any of the numbers that are here on my number line and plug them into the function, I'll be at some positive y value. Okay, so f of x, the function values are greater than 0, so above the x-axis, if x is between negative infinity and negative 2, union 4 to infinity. So same thing over here on the far right side of my x-axis. If you plug in a 5 for x, you'll get a positive value back. If you plug in 4.1, you get a positive value back. If you plug in 22, you'll get a big positive value back. Okay. So any number that's within either of those two intervals. Okay, and then when is it less than 0? The second part of the question. So that's going to be, in this case, in between our two x-intercepts. Okay, that's when we're at this portion of the parabola, portion of the u that's below the x-axis. So f of x is less than 0 on this interval -2 to 4. Okay, part C. F of x is -x squared plus 4x plus 5. This time our parabola opens down, so it's concave down. The others have been concave up. I know that because of the negative that's out front. Let's find the vertex. So x is equal to -b over 2a. -b is the opposite of 4, so -4 over 2 times -1. So I have -4 over -2, which is 2. We'll plug that in. So f of 2 is going to be 2 squared, which is 4, and then I take its opposite. So -4 plus 8 plus 5. So we're at 9. So the vertex is 2, 9. I think I forgot the axis of symmetry for the last problem. Remember, the axis of symmetry is the vertical line that goes through the vertex, so x is equal to 2. All right, x-intercepts. We will let y equal 0. So I have -x squared plus 4x plus 5. All right, let's factor out the negative because I want it to be a happy face problem. I want it to be easy to factor. Okay, so factoring the guy that's here inside the parentheses. Two numbers multiply to be -5, add to be -4. So -5 and 1. X minus 5 times x plus 1. So we get x is equal to 5 and x is equal to -1. So factoring out the negative doesn't affect my x-intercepts. From this point, if we wanted to, we could multiply both sides of the equation by a -1 to make that negative go away, and you still have 0 on the left-hand side. All right, so the x-intercepts are 5, 0, and -1, 0. The y-intercept will be 0, 5. So just plug in a 0 for x, and we get 5 back. -1. I determined that the vertex was at 2 when x is equal to 2, so this makes sense. It's 3 units to the left of 5, 3 units to the right of -1. So 2 is that middle point. So 9 is way up here. So 2, 9 is my vertex. The y-intercept was 0, 5. That's about right here. And we said that the function is opening down. Okay, so here's a rough sketch of the graph. Based on symmetry, if I start at 2, if I start at the x-coordinate of the vertex and go 2 units to the left, I'm at the y value of 5. So if I go 2 units to the right, I should also be at the y value of 5. So the coordinate for 5 should also be on your graph. Okay, good. And we're doing that based on symmetry. So remember, the graph is symmetric about its axis of symmetry. So this line x is equal to 2. Good. Domain, still all real numbers. The range is going to be from -infinity this time up to 9, including 9. So this time we're getting these negative values back on our y-axis, and the highest we get back is 9. Okay, determine where the quadratic function is increasing and where it is decreasing. This time we start off increasing, so it's increasing -infinity to 2. And then it is decreasing, starting at 2 and moving to the right, so from 2 to infinity. The sixth part, determine where f of x is greater than 0 and where f of x is less than 0. Okay, so greater than 0, remember above the x-axis, so this time in between our two x-intercepts is where the function is greater than 0. Okay, so f of x is greater than 0 on the interval -1 to 5. So this means it's going to be less than 0 outside that. So if we're to the left of -1, so -infinity to -1, or if we are greater than 5, so 5 to infinity. Okay, so you should see that we're just breaking up the x-axis. So intervals of increasing and decreasing. It's like I broke the x-axis up when x was equal to 2 because that's where it switches from increasing to decreasing. And the determining where the function is greater than 0 versus less than 0. We broke the x-axis up in 3 portions this time, so negative infinity to negative 1, and then in between the x-intercepts, and then to the right of the second x-intercept. Okay, part D, and I believe this is the last one that I do, and then part E you guys are doing and turning it through Canvas. Okay, vertex, so x is equal to negative b over 2a, so negative 6 over 2 times negative 2. The negatives cancel, so we'll get 6 over 4, which reduces to 3/2. And now we need to plug it in. So we'd have negative 2 times, so 3/2 squared is 9/4, plus 6 times 3 over 2, and then plus 2. So we'll have, let's see, this reduces, so we'll have negative 9 over 2 plus 9 plus 2. So negative 9/2. We could, okay, so we could either just get a common denominator, so negative 9 over 2 plus 11, which is 22 over 2. So we're at 13/2. Okay, or negative 9/2 is the same thing as negative 4.5, and then we're adding 11. So we're at 6.5 or 6.5, right? So either way you wanna write the number. Okay, so our vertex is at 3/2, comma 13/2, and again, either a mixed number or a decimal actually might be easier here since we need to graph it. Okay, concave down again because we have that negative, the negative out front. The axis of symmetry is the vertical line that goes through the vertex, so x is equal to 3 over 2 will be the axis of symmetry. Okay, x-intercepts, so set it equal to 0. And solve. Let's take out a negative 2 as I rewrite it. So I'm going to factor out the negative 2. So I'm left with x squared. The middle will switch to minus 3x and then minus 1 at the end. Distribute the negative 2 just to check. Negative 2x squared plus 6x plus 2. So we're good. All right. If we're factoring this, we're looking for two numbers that multiply to be negative 1 and add to be negative 3. Okay, well, no numbers do that. Okay, so let's go back and look at the graph to see if we think there should be x-intercepts. Okay, so our vertex is at 1.5, 6.5. Okay, so put that about right there. And it's opening down. So yes, there should be two x-intercepts. If our function was opening up, then there wouldn't be any x-intercepts, but since it's opening down, we can see that there will be. Okay, so that means we need to switch to the quadratic formula. And I'm going to use what's here inside the brackets or inside the parentheses because the numbers are smaller, so it's easier. Okay, again, if you just divide both sides by negative 2, that negative 2 will go away, so it's not affecting our answers. All right, so x is equal to the opposite of b plus or minus the square root of b squared minus 4a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1 or 2. All right, so we get that x is equal to 3 plus or minus the square root of, this will switch to a plus 4, so 9 plus 4 or 13, all over 2. Okay, so these are our x-intercepts. We have 3 plus or minus the square root of 13 over 2, comma 0. Good, they're not pretty numbers, but those are the x-intercepts. Okay, you can find a decimal approximation if you want to put them on your graph. But if I just ask for the x-intercepts, I want the exact values of the x-intercepts. Okay, y-intercept is easier. That's going to be 0, 2. Again, just plug in 0, and we'll get 2 for our y value. So remember, our vertex was at 3.5. So I went 1.5 units to the left. So if I go 1.5 units to the right, I should be at the same y value. Okay, and now we can sketch it. Okay, so when you find a decimal approximation, if you do, one of the numbers should be negative and then one of them should be greater than 3. Okay, based on my picture. Okay, domain, all real numbers. Range, let's see, I'm going to erase some of this. So the domain for all of these is going to be all real numbers. The range, we're coming from negative infinity and going to that high point of our vertex, which was 6.5. So negative infinity up to 6.5. Okay, increasing, decreasing. For this function, we start off increasing, right? So on this first portion of the x-axis, it's increasing from negative infinity until we get to 3/2. After that, it is decreasing. So from 3/2 to infinity. Okay, so the second portion of our x-axis. Intervals determine where the function is greater than 0 and then less than 0. So greater than 0, we're looking here in between our two x-intercepts. Okay, so f of x is greater than 0 in between our two x-intercepts. So remember, our x-intercepts are these not so pretty numbers, 3 minus rad 13 over 2, and then to the second one, which is 3 plus rad 13 over 2. Okay, so then this means that our function f of x is less than 0 when we're outside those x-intercepts, so negative infinity until we get to 3 minus rad 13 over 2, and then 3 plus rad 13 over 2 to infinity. Okay, so we have this portion here on the left, and then this portion here on the right of our x-axis. Okay, so everything that's here on the left, less than the first x-intercept, greater than the second x-intercept. If we take any x value there and plug it into the function, we'll be at some negative value. Okay, good. The next one, example 2e, is for you to complete and turn in through Canvas. So f of x is negative 2x squared minus 8x plus 1. So answer the same questions that we've been doing. Find the vertex and the axis of symmetry. Determine if the graph is concave up or concave down. Find the intercepts, graph the function, domain and range, increasing, decreasing, and then where the function values are greater than 0 and then less than 0. Good luck. Let me know if you have any questions.